So how do we find the mass of a star looking at a planet that is orbiting the star? So if we know the orbital period t, or when the radius is r, can we find the mass of the star? Like for instance, we have a planet like Earth, and we know it takes 365 days to orbit the sun, and we also know the distance from Earth to the sun. So can we calculate the mass of sun? Or say for instance, Jupiter, we know the distance of Jupiter from sun, and we also know how long it takes for Jupiter to orbit the sun. Can we find the mass? So let's look at the equations that we looked at before, the two. One is the Newton's universal gravitational law, and the second what we use for circulation motion. We discussed this in previous videos, and we derived the formula for the orbital period and also orbital velocity. So this one is to derive a formula for the mass of the star. So in this scenario that we have got a star, say with a mass m, and we got a planet with a mass small m. So we know the period t and the orbital radius r. So if we use those two equations, which is one is the universal gravitational law for the force, and then we equate that with the centripetal force, because centripetal force is provided by the gravitational force. So let's write those equations. So m v squared over r is equal to g m over r squared. So from here, this is capital R. So m is equal to, so we multiply these m v squared r squared divided by g m r. So in this case, that r will cancel out this, and m will cancel each other. So what we have got here is r v squared divided by g. So we know that v is 2 pi r divided by t. So if we substitute that, so there is equation 1 and equation 2. So from equation 1 and 2, what we get is mass m is equal to r v squared, which is 2 pi r over t squared divided by g. And if we solve this, what we get is 4 pi squared r cubed divided by g t squared. So the mass of the star is equal to 4 pi squared r cubed divided by g t squared. So what we have got here is, we know the radius and we know the period, orbital period. So if the radius and orbital period are given, we know how to find the mass of the star. And this is quite practical, because if you want to find the mass of a distant star, not sun, something far away from sun, we find a planet that is orbiting that particular star, and we find out how far that planet is from that star, and also we find out how long does it take for that planet to orbit the star. So those are the two things we need to find the mass of the star, which is amazing. So this is a question about finding the mass of the sun based on the information given about Jupiter. So Jupiter has an orbital period of 12 years, and average orbital radius of 780 million kilometer. So use the information to calculate the mass of the sun. So we know that orbital period is 12 years, that's given to us, and the radius is 780 times 10 to the power 6 kilometer. So if you are given the question, that it's important for you to derive the equation for the mass using the steps that we described before. So what you do is that you need to use the Newton's gravitational law and use that equation for the force to uh, derive the mass. So this is the equation for the mass of the star, where we go the radius r and the period t, and we know the value for g. So all that we have to do is substitute the values, and we need to make sure that we use the correct units. Uh, the distance should be in meter and the period should be in seconds. So we need to convert the 12 years into seconds. So if we do that, so that's the answer we get. So the answer we get will be 1.96 times 10 to the power 30 Newton minus 1 kilogram 2 m is minus 2. So this will be equal to 2 times 10 to the power 30 kilogram. So that's the mass of sun. So what we used to find the mass of sun is the period of Jupiter and the orbital radius of Jupiter, and we use this Newton's gravitational law and the equation for the circular motion to find the mass of sun. And you might notice that it's in kilogram, but here we have got all these units. Do you know how we got that? Because Newton is basically, if you remember that uh, the equation F is equal to ma, the force is equal to mass time acceleration. That's Newton is basically kilogram meter per second square, right? So if meter per second square, if it comes down, so you will have kilogram left here. So if I write it down, say um, this one, we got Newton minus 1 kilogram ms minus 2, right? So the Newton minus 1 is basically 1 over Newton. So kilogram square ms minus 2 divided by Newton is kilogram ms minus 2. So what is happening is that this will cancel out, right? This will cancel out, and what we have got is 10 to the power 30 kilogram. So that's the mass of star.